All right, so we are recording. Perfect. Yes, so please do make sure you do those passports. We're supposed to check it every day, but they've realized it's kind of unfeasible and a little goofy to walk around because there will be so many easy ways to get around it. And so what we're going to be doing instead is I get an email every day that says who's not in compliance, and it starts at the beginning of the day. And so if you finish filling out that health check before class, I'm just going to have your name on a list, and you can come and show me that as well. Looks like we're not going to have any issues with people wearing masks. Thank you. Just to give you some transparency, if any of y'all decide to come to class without a mask, I tell you to put a mask on. If you don't put a mask on, I'm going to pause class, try to talk to you individually, and if you still don't put a mask on, I have to cancel class. So let's just make this easy for everybody. I'm going to try to figure out what's the best answer for lecturing, even with a mask. Or I have a face shield. The face shield makes me feel like an astronaut, so I may start wearing that. But it is a little goofy to walk around in. Lecturing through a mask is a little strange, and so I may have to wipe my face to get the sweat off. Yes, yes, I will upload the files to Canvas under the Files section. As I said last time, and as I sent out in a message, all of the recordings will also be uploaded on YouTube. Again, it's not monetized. I don't make any money, so don't worry about that. They came up one time. And there are some web browser extensions that you can actually download. This is good advice in general. That will block YouTube ads, and so it makes it really easy. This way you can access it from wherever. All right, a couple questions. Let's go through. All right, what day does blue group come to class? I don't remember which is blue, which is silver. What are y'all? Today. So, sorry, Deja. You can come today, or you can just keep doing this. Oh, thank you, Skylar. Monday and Tuesday. There's no lecture tomorrow. If I said Tuesday, I apologize. Just think of this class as a normal semester's class. It's Monday and Wednesday. You just can't come one of the days. And so you will access it through Zoom, and we will do it that way for there. Perfect, you guys are answering. If y'all see I'm answering a question that somebody's already answered, feel free to tell me to shut up. I don't have very thin skin. So, all right, any other questions? Comments, concerns, declarations?
Do you have the Wi-Fi password?
I do. So there should be two. There's a faculty one and there's a student one. I don't know the student one. I do know the faculty one, but I probably can't give out the faculty one. Does anybody know the student Wi-Fi, or how do you get that? Yeah.
It's no chargers, capital G, capital C, and then exclamation.
Oh, perfect. And actually, I have totally spaced. If you want to come up and just really quickly, I'm going to talk near my computer so the people on Zoom can hear you. Who recognizes who this is? Okay, a couple of you watched your infamous video.
Yes, they did. So I'm Luke Worley. I'm going to be your pass leader this semester for Psych 300. I sent out an email earlier over Canvas, kind of detailing to look over Dr. T's email earlier about when our pass session is and the surveys. So our session times are going to be Monday 11 to 12 in person in Morton 286, Tuesday 1 to 2, and these are going to be online, and Wednesday 2:30 to 3:30 in Morton 286. And I will send out another email about when these are and detailing it and what's going to go over each section and as well each day that we're going to have a session as well. You guys have any questions for me?
What did you say the Wi-Fi password?
It's Go Chargers, capital G, capital C, and an exclamation point at the end. And there's no space.
Any other questions for Luke? Luke's going to be an awesome resource for you all. I think he got like 102% or something when he took this class. 103. There you go. Yeah, so he's squared away. Yes, sir.
In a week, you have on your syllabus that will be covering 2 different subjects or modules. So on Wednesday, if we don't come to class, like if we're not the super group, we still need to tune into Zoom.
Yes, yes. So again, this is going to be like a regular semester. Just think of it as one day you decided to work remotely. So there will be 2 different lectures every class, not every class, excuse me, every week, 1 different lecture every class. So for the days you are not coming in person, you'll access through Zoom like all of these lovely people on there. Good question. What else? All right. Show of hands, who's dreading statistics? Perfect. And I suspect some of you all are just not willing to admit that you are. As I said on my intro day, I hated statistics. I genuinely hated statistics. And I think that's because A, I just didn't want to go into math, but B, I kind of convinced myself that it was impossible. And I think the biggest barrier I see for a lot of students in this class is you kind of wig yourself out. Like, I'm not a numbers person, so I don't want to do numbers. But in reality, frequently when people come to me like, I can't do it, they know what they're doing. You just kind of have to talk yourself out of the anxiety associated with doing the math. And we're going to build on the concepts, but because statistics is a math-based course, everything's going to build off of one another. And so if at any point this semester you start feeling yourself getting behind, the best bet is to ask for help early on. Because if you come to me right before the final exam and say, Dr. T, I'm really struggling with measures of central tendency, which is what we're going to be covering the next week or 2, you're going to be in a world of hurt for the final exam. And so make sure that you're on top of it as we go through the semester. If you want to meet in person, we can do that. I prefer not to, but we can do that. I've got enough space in my office and go over it. But otherwise, this summer I invested in an Apple Pencil and I have my iPad, and so we can go over all the tutoring you would need via Zoom. And that's also what I'm going to be using for this class for when y'all are accessing the class remotely. So we can record that screen. We don't have to worry about resolution on the small board here. It is somewhat goofy that they've chosen to cover up 2/3 of the board with the overhead projector, but alas, here we are. All right. Yes, he will send out another email. All right, so here's your fun fact of the day. Bones at Seymour Island indicate that 37 to 40 million years ago, penguins stood at a formidable 6 feet tall and weighed 250 pounds. It's terrifying. I wonder if they still waddled as much as they do now. I feel like waddling at that big, you'd fall over. Whoopsies, wrong version. All right, so let's go ahead and get started. We're going to start very elementary here. What is a variable? We're going to be talking about scientific experimentation throughout the semester. We're going to be talking about different types of variables today. We'll start from ground zero. A variable is just a characteristic or a condition that can change or take on different values. So when we think about research, we have a general question about the relationship between 2 variables. So for instance, does wearing a mask reduce the spread of the coronavirus? So when we're thinking about actual experimentation, we're going to have a couple different principles we're relying on with things like random selection and random assignment. But when we're primarily interested in doing research, we have a population from which we are pulling from. That population could be the entire world population. It also could be a smaller subset. So let's say we were only interested in UAH students. UAH students would then be our population. So don't get confused when we say population. We don't mean necessarily the 7 point whatever billion people in the world. That population is just whatever is the base group that we are interested in evaluating. So for example, let's say a researcher is interested in the relationship between class size and academic performance for the population of third grade children. So we have our two variables, class size, academic performance, and then the population is all third graders. Now, we're not going to study all third graders, but that's the population from which we are pulling and then trying to extrapolate. That group we pull from the population is known as a sample. Now, oftentimes, the population is so large that it really would not be feasible to study everyone in that population. So for example, again, if we're studying something about UAH students, we want to know if UAH students are better than UAB students at statistics. It doesn't make sense to get all 10,000 UAH students and all 20,000 UAB students and evaluate, because that takes too much time, too many resources. So what we're going to do is pull a sample from UAH, pull a sample from UAB, and then compare. Sorry, I smacked the mic. And what we want to do is have what we call a representative sample that we pull from. A representative sample, we just mean that there's no systematic bias to how we selected people. It would not be a good sample if we pulled only those who had taken statistics from UAH and only those first-year freshmen from UAB. Right? Those would not be representative of the populations as a whole. So this is just graphically representing what I already said. You have the population, all the individuals of interest. The sample is then selected from the population. So we have that sample that's going to participate in the research study. And then, if we've done the study correctly, we're going to generalize from that sample to the overall population. Questions so far? All pretty straightforward? Perfect. All right, so when we talk about variables, we talk about two different types, two different broad categories of variables. Discrete and continuous. Discrete variables consist of indivisible categories. So, for example, number of siblings you have is a discrete variable. I know we talk about half siblings, but it's not really half a person. Or maybe it's better to think about class. We have a certain number of people enrolled in this class. You can't have, 0.23 of a person enrolled in this class. You may have 64, you may have 65, but you cannot split up that number more than this whole jump. Continuous variables are things like time or weight that are infinitely divisible. Right? So you can have a foot, you can have an inch, half an inch, quarter, 32nd, a thou, etc. Now, you can choose to round those continuous variables to the nearest whole. But the units of measurement, or the scale itself, which we'll talk about scales in just a second, is itself continuous. Somebody give me another example of a discrete variable. Yes, ma'am.
What do you mean, number of items purchased?
Yeah, number of items purchased, exactly. So you go to the grocery store, you have a certain number of items that you have purchased. You can't really purchase half a box of Oreos as much as you might want to. Somebody give me an example of continuous variables. Another continuous variable.
Length,
What's that?
length, like you can measure it in meters.
You kind of cut out there, I'm sorry.
I said length.
Sorry, William, it's not coming through all the way here. You say length?
Yes.
Yes, length, exactly. Yep. And so you have a mile, or you can have any fraction of a mile. Here's a good day because you're going to get a bonus fun fact. There are as many numbers between 0 and infinity as there are between 0 and 1. Well, that's a percolate a little bit. It's infinitely divisible, right? You can make a fraction out of 0 to 1 that's representative of every number between 0 and infinity. Yeah, so discrete, how many buildings are on campus, how many plants you own. Yeah, great. We then have these real limits. And these real limits are essentially the cutoffs for that continuous variable. So we establish real limits, which are boundaries located exactly halfway between adjacent categories. And you all intuitively know this, right? So if 90 is an A and an 89 is a B, any one of y'all that get an 89.5 is going to come to me and say, hey, round up. We're at the real limit for an A. Right? So you establish what is that real limit that allows me to make that jump to that next category.
So how would that be halfway between the categories?
The category is 89 would be a B, 90 would be an A. Halfway between 89 and 90 would be that 89 and a half. Exactly. Yep, good question. Can somebody else give me another example of a real limit, maybe in everyday life?
Speed limit,
Speed limit, okay, how so?
I don't know, if you're going less than, if you're going greater than 60, you could get a ticket, but if you're going less than, but there's not really a halfway, I guess.
Yeah, but I think you're on something. So when you get pulled over, God forbid any of y'all have ever been pulled over by a cop, they'll never say you're going 79.5 miles an hour, right? It's 79 or 80 miles an hour, right? So establish a real limit, at which point they will round down to the category of 79 or up to 80. And this really becomes an issue when you get into things like classification of reckless driving, right? Below a certain amount is not reckless. Above that amount is reckless. I don't know what the classification is in Alabama, but if we were to say 10 over would be reckless driving, 79.5 makes a big difference, right? And now you're getting rounded up to 80, you're a reckless driver. Come on now. All right, critical thinking activity. So for those of y'all, it's above 15. Ace, I'm concerned that you know that. Also, I think I saw you driving in your video here. So, all right, so take some time. If you're here in class, you can talk it over with your neighbor. So get close to them. And if you're at home, think about it critically, but determine if each of the following are discrete or continuous. Height, number of oranges in a bag, distance, country of origin, and cuteness of said puppies. Ready? Talk it over with your neighbors. All right, what do we think height is? Discrete or continuous? Continuous, exactly. What about number of oranges in a bag? Discrete, yes. Now, I'm sure some of you are thinking, well, can't you just chop up a whole bunch of oranges? In theory, you could, but we're going to pretend like you're going to the supermarket. You can't just chop up the oranges wherever you want to. What about distance? Continuous, yes, you can split that up. What about country of origin? Discrete, yes. Yeah, you can't be halfway in between the U.S. and Costa Rica. Right? That doesn't make sense. And then what about cuteness? Kind of a trick question. It can be whatever you want. It depends on how you are determining this, right? You could have a classification of, cute, very cute, extremely cute, and oh my God, so fluffy and cute. That would be discrete. Or you could have potentially a sliding scale, at which point it would be continuous. Good. Any questions at this point so far?
Wouldn't those categories of cute just be real limits of continuous?
You mean where I say cute, very cute? That's a very good question. You're getting into a very kind of epistemological conversation about what is the knowledge, what is our understanding of cuteness. In this case, the actual labeling, we would say we're just treating as bins, like colors, or just general categories. You could, in theory, have a number range, at which point you say, okay, below 5 is cute, 5 to 10 is very cute, 10 to 15 is extremely cute, etc. And that actually gets into a conversation within the field of statistics about how do you treat things like Likert scales. Does anybody know what a Likert scale is? So I'm sure you all have experience with it. It's the, from 1 to 7, how happy are you today, right? From very unhappy to very happy, right? There are some people who treat that as a continuous scale. There are some people who treat that as a discrete variable. And in reality, the answer isn't all that solved for the scientific community, but you're kind of highlighting on one of these issues that there are some kind of gray areas into how we actually treat these sorts of things. But think about the kind of extreme examples. All right, so when we're measuring our variables, we want to make sure that A, the variable we've selected, is the variable of interest, and B, that the measurement we're using for that variable gets at what we actually want. And so if we said, all right, we're going to measure somebody's intelligence, what's a scale everybody knows for intelligence? IQ, right? That makes sense. Now, I, as a researcher, could come and say, okay, well, the only test we need to give for intelligence is, are you a Dallas Cowboys fan? Are there any Dallas Cowboys fans here? Sorry, buddy, I'm going to pick on you again this semester. If you're a Dallas Cowboys fan, we know you have below average IQ. If you're not a Cowboys fan, we know you have above average IQ. Well, that may not be the best measurement or best scale to get at that variable, right? So we can all agree on the variable we should be interested in, but what is that scale of measurement that we're actually going to be using for ascertaining that information? And so the scales we're going to be using in statistics fall into 4 different categories. First is a nominal scale. And a nominal scale is an unordered set of categories for which you can only exist in kind of one, right? So for example, what school do you go to? UAH, right? That is, in and of itself, a category. There are not varying levels of UAH students in here. It's not like some of y'all are 90% UAH, 3% Auburn, and 7% Spring Hill College. Right? You're either a UAH student or you're not. It's also important to remember that these nominal scales are not essentially value judgments. You can't make determinations between the groups as to which is a higher group or a lower group. So who can give me another example of a nominal scale? Yeah, Sunny. Favorite color, exactly. Yeah. So let's say we've established, okay, we're only going to use the visible spectrum. So Roy G. Biv, what's your favorite color? Well, you pick a color in there, and now we've got everybody's actual favorite color. Somebody else give me one more example of a nominal scale. Favorite TV show? Yes. Any answer other than The Office is wrong, just FYI. The second scale is what we call ordinal. An ordinal, like its name would suggest, is an ordered representation of the data. So think about the place you finish in a race as being an ordered scale. You know that 1 came before 2, 2 came before 3, 4, 5, 3 came before 4, but after 1, right? You've got the order in which they came in. And so this is, again, where we get into the Likert scale question. So if I said on a scale of 1 to 7, how much do you like Nick Saban? You can't tell if somebody's jumped from 1 to 2 is the same amount of liking increase on a purely phenomenological, experiential type of question as it would be from 6 to 7. Right? Let's say you rightfully despise Nick Saban. You give him a 1. And then you find out he volunteers with the soup kitchen downtown. Now you're going to jump to a 2. Or let's say that you really like Nick Saban at a 6, and then he wins you another national championship and you bump up to a 7. It's not logical to say that the amount of increase in your liking of Nick Saban is the same from 1 to 2 as it would be from 6 to 7. But it is logical to say that the person who likes Nick Saban at a 6 likes Nick Saban more than the person who likes him at a 5. Does that make sense? Yes.
About not the 6
Yeah, so, let's say I personally despise McSaver, so I give him a 1. If he did something to make me bump up to a 2, like him just a little bit more, I still don't like him all that much, but like him just a little bit more, that 1 unit increase from a 1 to 2 may not mean the same amount of increase in how much I like him as if I went from a 6 to a 7, for example. Does that make sense? Good question. So the relativity is subjective. I'm not totally sure I understand the question. Do you mean like the relative nature between the degree to relativity is subjective? So if you mean like, is the fact that I understand 2 is greater than 3, or excuse me, 2 is greater than 3. Lord almighty, I need more caffeine. 2 is less than 3, and thus, if I like him more, I should give him a 3, then yes, that is entirely subjective. I'm gonna wait until, is that kind of what you were asking? Okay, cool. Yes?
So if you wanted to like, grade just for one of them, would that be
Yes, exactly. So, you'll get a percentage for this class, but after that, you're just gonna get a letter grade, and that's gonna go in your transcript. And I'll be able to see what your letter grade was, and know that the jump from, well, there are kind of confounded ways in that, but, so the jump from a B to an A would be the same as the jump from a D to a C, but the amount of that jump could differ as a function of what your actual percentage in the class was. So I would actually caution against thinking about this specifically as an example. But you're on to kind of the right idea in that you have these orders, but it's not necessarily logical to say the jump between these 2 positions will be the same. So do you have any siblings? Do you have any siblings?
Yeah, I do.
Okay, so it would make sense to say that the jump between, you said you have a younger sister and older sister? Oh, a twin sister and older sister. So it would make sense to say that the jump between your younger sister and you is a 1 unit increase in the sense that like you came first and then your younger sister. It would also make sense to say that, are you the older or the younger of the twins?
I'm the older.
Okay, so it would also then make sense to say that the jump between your twin sister and you was a 1 unit increase in the sense that you are older. And you could derive from that that your younger sister jump to your younger twin would be a 1 unit jump. But it wouldn't be logical to say that those are the same degree of jumps. Does that make sense? Other questions? Man, my upper lip is sweating like nobody's business right now.
I have a question.
Yes.
Is it safe to say that the nominal scale is more name-based categories and the ordinal scale is more like number-based, or have some type of like order kind of?
Yes, exactly. So nominal is essentially name-based. That's a very good way of putting it. Nominal is name-based. It's these categories. Ordinal can be categories, but there's a representation of order to those categories. So we know the first sibling came first, the second sibling came second, third sibling came third. We understand that direction.
Like the alphabet too?
Yes. Yeah, I think you could think about it that way. Yeah, tall, taller, tallest. Yes. All right, an interval scale is an ordered set of equal sized categories, but there is essentially no meaningful 0 point. The 0 point is just somewhat haphazardly put on that scale. The distance between points is the same across that scale, but the 0 doesn't have any meaning. So think about temperature in Fahrenheit. You jump from 10 degrees to 20 degrees is the same amount of energy increase as you get from 110 to 120. But 0 degrees doesn't actually mean 0 energy, right? That's why you can have negative temperatures. You all may remember in some of your earlier science classes, maybe in high school, maybe when you got here, learning about the Kelvin system of temperature. 0 Kelvin literally means 0 temperature, no energy, no movement. 0 Fahrenheit, 0 Celsius don't mean that. So it's kind of just whatever. Put there because we decided to put it there. Ordinal is like first, second, third in a race. The person who got second could have, whoopsies, been super close to the person that got first, but they are still less than the person who got first. Yes. Yes, and so it doesn't matter if you lose the person in first by a second or by an hour, you're still second. All right, so yeah, so an interval scale, meaningful distances between the points on the scale, but 0 has no meaning. A ratio scale is just like an interval scale, except 0 has a meaning. So think about weight. If you have a 0 weight, that means you literally weigh nothing. There's 0. For Kelvin for absolute 0, that would be an example of a ratio scale. For Fahrenheit, 0 doesn't really mean no temperature, right?
Well, couldn't you just use some measurement that 0 is like actually
You could, yeah. But the way we measure weight currently, yeah, so you could absolutely screw with the scales themselves to change them. Like you could change weight into an interval scale if you wanted to. But the way we classify weight, like poundage or kilograms or things like that, are on a scale in which 0 actually means 0. Good question. Other questions about these different categorizations? Yeah. Sorry? Question is, would height be an interval? What do y'all think? Somebody give me a definitive answer. No, why not? Exactly. So in the case of height, you could have a 0, which means you literally have no height, right? You cease to almost exist. Does that make sense? And so a ratio, it would be a ratio scale because 0 means 0, no height. Cool? Awesome. Amber says ratio scale is like how bartenders make drinks. Give me an example.
Like you would put 1 part vodka and 1 part, or you would put 1 part vodka and 3 parts Coke. So it would be a ratio.
Yeah, so in the sense that 0 parts Coca-Cola means literally 0 Coca-Cola.
Yeah,
right?
that means exactly. It'd be like just a vodka shot.
Perfect. Glad in the second class of the semester we're already talking about alcohol. I'm going to lose
You're
my...
welcome.
No, I'm kidding. All right. Height depends on the questions being asked. Tall, taller, tallest, or ordinal. Yes. Yep. Good idea, Kenya. All right. So ratio allows you to say twice as tall, right? Because you have a unit at which you can anchor that absolute value. So you can say that 6 feet is in fact twice as tall as 3 feet. You can't do that with interval data. We do all the time, we do colloquially, but it's actually illogical to say it's twice as hot down here as it is up in Canada. Because it's not really. We've established an arbitrary zero. Does that make sense? But even then, it wouldn't be twice as hot, right? It would just be a few units increase of Kelvin.
Yeah.
Yeah. Any other questions? Yeah, somebody else try to give me an example of an interval scale. Yes, I will in just a second, Ryan. Can somebody give me another example of an interval, and then I'll explain why that's an interval or how that's an interval. Would grades be an example? Not really, because 0 would actually mean you have 0 points, if that makes sense. So that would be more of a ratio. So you can think of a real world example.
So personality tests.
Okay, yeah. So let's say you've got a personality test that ranges from, 0 to 100, or whatever the construct is. Having a 0 doesn't really mean you have 0 personality, right? You say things like that colloquially, oh, he's got no personality. But it doesn't actually mean 0, right? So when you think interval, think about things where 0 doesn't mean anything. 0 is just, for some reason, we decided to flip the positive to negative at that point. So we can also think about, for example, truth be told, Jessica, I don't know how credit score is calculated, so I'm going to hold off on that one. Happy to sad, yeah. So if we do, again, it's tough because it really depends on how you're actually framing this measure. But think about any construct in which you could assign 0, which doesn't really mean none. So let's think of another example here. Right. Yeah, that's a good example. Yeah, so your brightness setting on your phone, you can take it down to 0, but your phone's still on, right? It's still projecting. It just means 0 because that's where they decided is the lowest that they want to have. That's a really good example, yeah. So you can go all the way up, and the unit increases from 0 to 1 is going to be the same as from 9 to 10, but 0 doesn't really mean 0 brightness because there's still brightness there. Does that help? I apologize if I keep butchering people's names. Ryan?
What about like military time?
Yeah, so like 0, 100 hours? Yeah, I mean, it's not really 0, exactly, yeah. I think that's probably a good example. Hours of sleep would be ratio, because 0 hours of sleep literally means you got no sleep. Favorite color would be nominal, because that's kind of a bin, a category. So my favorite color is red, my favorite color is blue. So happy to sad, again, it really depends in the sense that, I mean, you could in theory have 0 happiness, I guess, depending on how you ask that question. And so that's the only reason I'm hesitating to say absolutely. But as long as you have a conceptual understanding that in an interval scale, 0 means really nothing. It has no meaning. In a ratio scale, 0 means 0. 0 means zilch, none, nada, zip. And I think All right, we're going to move on, but if you do have additional questions, let me know. Question was, so what were the other examples other than phone brightness for interval? We talked about, so Fahrenheit, for example. 0 degrees doesn't really mean 0 degrees. It's just what we've established. It can be a little tricky because we have so ingrained in ourselves culturally that 0 in Fahrenheit means 0, and when we say it's going to be twice as warm tomorrow, we jump twice as warm, but it's an actually illogical statement to make based off of the type of scale we are using.
What about something like your bank account? Like it can hit 0, but it can also go negative.
So that's a really interesting question. I mean, in that case, the negative is kind of it's kind of arbitrary in the sense that you don't really have negative money because negative money is not a thing. It's their way of indicating that you owe them money. If that makes sense. Yeah, so I would think of that more as a ratio scale because 0 literally means you have no money. And so you're right that it can go into the negatives, but that negative is kind of, I wouldn't focus too much on the negatives because that's just kind of a representation that the bank has established as saying, hey, Bozo, you owe us money. Cool.
So what about like a charge of like atoms?
A charge of what?
On like an atom. Maybe it could be positive or negative.
Oh, you're getting into domains that I'm not all that comfortable speaking about. So, I think that would still be ratio, because 0 still means no charge, right? So, if 0 has some meaning, like literally means nothing, like there's nothing there, that's a ratio. Otherwise, it's an interval. Can you have subjective scales in interval and ratio scales? Yes, and the only reason I say it like that is because you get kind of into questions that are going to extend beyond this class in the sense that can subjective experiences in fact be kind of absolute in our judgments, and that's up for debate. So we'll say yes for the purposes of this class, but know that that's a really soft yes. All right. All right, so we have different types of studies, one of which that we will talk about mid-semester in the actual calculation of this is called a correlational study. And so a correlational study is designed just to see whether there is a relationship between two variables. It simply observes the variables as they exist naturally. For example, is there a correlation between the percentage of people that wear masks in a city and the number of COVID cases in the area? That would be a correlational study. In this case, they're simply trying to observe these two variables. They're not trying to determine causality. And so in this case, let's take a look at this example. On the x-axis, we have wake-up time. On the y-axis, we have academic performance. And this is saying, okay, is there a relationship between when you wake up and your performance in class? Now, if you were going to draw a line through this, you would likely draw it from the top left to the bottom right, because that's what the data actually look like. And so this would say that there is a negative, or there is a negative correlation, such that as the hours increase on the x-axis, the lower somebody's academic performance would be. If you're constantly waking up at noon, just in time for your favorite class, statistics, chances are you're not going to have the same GPA as somebody who's waking up at 6:30, 7.
Is that like an actual theory?
No, I just made that up. Wouldn't surprise me if that were somewhat legitimate, but you can obviously think of outliers, right? So this is one of the good reasons to say, okay, are correlational studies telling us about the relationship, or are they telling us about causal experiences between these variables? And so you can think of a reason why perhaps somebody's wake-up time would negatively impact their GPA. But you can also think about the inverse of that. So you can think about, okay, maybe somebody's really low GPA is keeping them up late at night, or they're studying really late into the night, so they're waking up later, right? So correlational studies are just saying, is there a relationship between these for the purposes of me trying to predict the future, rather than saying one causes the other. And so that is a really, 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 really important thing to understand. That correlation does not mean one variable causes another. And I pulled this from one of my favorite websites of all time that's just looking at spurious correlations. When I say spurious correlations, it means data that varies together that probably has no cause-effect relationship. So in this case, per capita cheese consumption correlates with the number of people who die by being tangled in their bed sheets. It's probably not the case that as people eat more cheese, they then get haphazard with their bed sheets, right? This is just a random relationship. They correlate together. So in this case, if I know how much cheese was consumed per capita, I can tell you with reasonable certainty how many people died by accidentally becoming tangled in their bed sheets. But that doesn't mean that one is causing the other. Another example, age of Miss America correlates with the murders by steam, hot vapors, and hot objects. It's probably not the case that as Miss America approaches 24 years old, people are like, I really want to go murder somebody with steam. It's just a random relationship, right? So I'm really trying to hammer home here. When you see correlational studies reported, frequently in the actual scientific article itself, it'll say there's a relationship between the two, in that knowing someone's position on one can predict their position on the other variable. But then you get to the popular press, and the popular press will say, this causes that, right? You'll see this all the time with like health things. They'll say, eating more nuts leads to living a longer life. Well, maybe. Or it could just be that those who are predisposed to eating more cashews, for example, care about working out as well. And so it's not cashews cause people to live longer. It's the working out. It's this third factor in there. Correlation does not imply causation. If you only take one thing away from this class, please, for the love of God, let it be this thing. I promise I will ask about this on your exams. Because you're going to see things all the time like this. You know, you want to live longer even if you're poor, then move to a big city in California. That's insane. That is an insane suggestion. What the study actually showed is likely the fact that people in big cities in California live longer than those who live in middle America, regardless of their socioeconomic status. But it's not saying that if you're poor in, middle of nowhere, Kansas, just move to San Francisco and you live longer. Right? There are a whole bunch of other factors that could be in play. Another one, fan in room seems to cut infants' risk of crib death. Do we really think that there's any association with having a spinning top on the ceiling and preventing a kid from dying in a crib? You can come up with very convoluted potential explanations, but it's likely the fact that these have nothing to do with each other, but they correlate with one another. This may be my favorite. Tooth loss and elderly linked to mental impairment. Okay, well, any sentient being at this point in their life knows that our brain is not in our teeth, right? And so losing your teeth doesn't really affect your mental faculties, but it could be that your mental faculties decreasing, losing your memory, leads you to brush your teeth less, which then leads to tooth loss. Or it could be some underlying factor that affects both. I don't know this. This is probably not even the case, but maybe Alzheimer's affects your genetic expression in such a way that both impacts your memory, but also impacts your tooth retention. Another one, diet of fish can prevent teen violence. I don't think that means if we just, force feed a really violent child salmon, that all will be well. All right. So those are correlational studies. Those are really good for looking at associations. You'll see a lot of correlational studies when it comes to COVID stuff, right? Because we can't control for it, but we can say, okay, here are overall behavioral changes, and that's what they did with masks, right? Here are overall behavioral changes. People that wore masks seem to be less likely to contract COVID. Now, it could be some third explanation, but those correlational studies are really good at then driving what we call experiments. And experiments are where we really try to establish a cause and effect relationship. Can we definitively show that wearing masks reduces the spread of coronavirus? What's that? Yeah. Well, and they're doing a lot of studies now, right? And so one of the really interesting things that I was actually talking to my intro psych class about before the whole coronavirus situation unfolded was that different moral philosophies between the East and the West manifest in our perceptions of mask wearing, right? So we've always seen over in the East, like in Japan, people wear masks frequently during flu season. And we always assumed, at least most Westerners assumed, that was because they didn't want to catch it themselves, right? But now we've gone through this learning process, and the lessons say the masks aren't really good for keeping you from getting infected, if there's stuff out there, but it's really good at preventing you from potentially spreading it to others, right? And so this is one of the things that you can do with these sort of cause and effect experiments rather, is establish, okay, let's control for everything else. Let's bring it into a lab setting, and let's put a mask on somebody. What happens when they inhale? Is this really filtering out any of the air? And then we can say, okay, what happens when they exhale? Is this really filtering any of the air that they're exhaling? Right? So this is where we get into the real control to say, okay, behaviorally, we've seen that there is a relationship between mask wearing and infection of COVID-19. But now let's look at the actual experiments. And when we run experiments, we say, oh, okay, it does look like masks prevent me, if I were to have it, from spreading it out there. So this is really where you get that cause and effect. So in an experiment, you're manipulating one variable, or sometimes more than one variable, but let's just say one variable for right now. You're manipulating one variable and measuring a second. And the goal is to keep everything else constant. Because if we can keep everything constant except for one small change, we know that the change in that dependent variable, that variable we are measuring, is likely due to the small change in the one we were manipulating. All right, so let's go back to the laboratory setting with the masks. Let's say we had no control. And so we had somebody just speaking, we're collecting all of that particulate matter in the air, and we're saying, okay, there is a baseline amount of coronavirus that somebody could expel. And then we say, all right, we're gonna do masks, but we have control for everything, and all of a sudden the fan shuts off, right? And so it could have been that having the fan on when we had somebody first talking and we were first collecting that data could have impacted our measurement of how much of this particulate is being expelled, which could distort our overall scientific findings by saying, look, there doesn't seem to be any benefit. Well, it doesn't seem to be any benefit because you had a fan blowing on somebody's face in one case and not in the other. Right? So you want control for everything in the situations. And so what you're manipulating in your experiment is called the independent variable, or the IV. What you're measuring is called the dependent variable, or the DV. All right, we're running out of time, so we're going to skip the critical thinking here. So the experimental setting is the best for establishing that sort of control. But we also have other types of studies, both non-experimental and quasi-experimental. So non-experimental would be things that don't really have any control whatsoever. And so you may have heard the news yesterday that the FDA has now approved use of convalescent plasma as a treatment. That was a non-experimental experiment, so to speak. It was non-experimental in the sense that they just collected whatever data they could, and then they ran statistics on it, and think that when controlling statistically, they think they found a benefit. But they didn't put 10,000 people in the convalescent plasma condition and 10,000 people in the non-plasma condition and see how much benefit there was, right? Because you then get into potentially ethical issues associated with, if we think there's a benefit, we're not giving it to these 10,000 people, that's potentially an issue. So that would be non-experimental the way they did it. They just gave it to people and said, okay, let's try to establish what potential benefit there is in that. You also have quasi-experimental. Quasi-experimental is the separation amongst characteristics that vary out in the real world. And so let's say we wanted to see if, men or women were better at statistics. Well, you can't assign somebody to be in the male group or the female group. You have this quasi-experimental variable in the sense that it varies out in the population, and now I'm just going to record people's gender and then look at their overall statistics performance. Right? So does that make sense how the difference we have in experiment, we're actually controlling for everything. Non-experiment, we're not really controlling for everything, or really anything in some cases. And then quasi-experimental, we're taking variables that differ out in the real world and using that as the barometer by which we then look at the differences. So you can think of another thing of, are extroverted people more likely to get a job after college? But you can't make somebody more extroverted, but we can look at varying levels of extroversion and see how that affects their ability to get a job. So because quasi-experimental and non-experimental don't really control for all the potential confounding variables or the strange variables, or the variables outside, like the fan, you can't really establish a cause and effect relationship. Right? So let's go back to the example of the men or women that are statistics. Well, maybe you have some third variable like stereotype threat, right? So there's been within social psychology this idea that kind of the framing of a class can affect people's overall perceptions of themselves and their own confidence, which can then affect their own performance in the class, right? And so maybe it's the case that the ground truth is there's no difference between gender in class performance, but you could have this outside effect, the stereotype threat effect, which is causing the difference, right? So because you don't have the complete control over all the variables, all the situations, you can't really derive a cause and effect. Skip that. All right. So the measurements that we collect, the dependent variables, are called data. Data itself is the plural. Datum is the singular. And I tell you this even in light of the American Psychological Association deciding that we've misused the word data for so long. They're now accepting data as a singular, but that drives me bonkers. Just because we misuse a word doesn't mean you can change the meaning of the word. So yeah, data is plural, datum is singular. And the goal of statistics is to take this data and make sense of it, organize it, and interpret it. So that's what we're doing in this class. We have these different variables that we're interested in. Does mask wearing help prevent the spread of coronavirus? We have these scales. What do they mean by the spread of coronavirus? Let's say it's the number of people that get infected. Right? So now we've got a ratio scale. We collect the data, grab all of that data, and then we have to look at it. And we have to say probabilistically, what is the likelihood that our observed patterns in the data are due to chance versus a ground truth that we've observed. Right, so think back to the example I said in the first class about flipping a coin. It's a lot more likely that you're going to get 100% heads when you flip a coin only twice than 100% heads when you flip a coin 50 times. And statistics is the process by which we can say at what point can we definitively say that at a certain level of confidence, this is observing the ground truth of the world. And we'll get into things like p-values and probability in future classes. And so once we've got all of that data, we have a couple different types of statistics we can run: descriptive and inferential. Descriptive statistics are giving you information about the population itself, or the sample itself. It's saying, what is the average value? We'll talk about central tendency, and we'll talk about variation. Don't worry about that yet. So the descriptive statistics are just giving me a good picture overall of what's going on with my data. Inferential statistics, on the other hand, are those probability estimates that allow me to say whether or not something is due to chance. Right? One of the biggest things in statistics to understand is if you sample two groups, there's always going to be difference. Just, it's almost never the case that if you sample 100 people from group A and 100 people from group B, even if there is in fact no ground truth difference between those groups, you still are going to have minute variations in the data. Maybe somebody's having a good day or a bad day. Maybe your measurement isn't precise enough. Right? Maybe you are on either side of that real limit, such that now you bump it up just a little bit, and that has a significant impact on the data. And so inferential statistics are just allowing us to establish what's the likelihood that the coin is weighted if I flip it 10 times and they all come up heads. We have intuition that that likely means the coin's weighted. But with statistics, we can get probabilities. We can say at a certain percentage probability, this coin is weighted. So that way, you don't have to just keep flipping the coin until the end of eternity to make sure, right? You can get to a certain point and feel confident at that point. We'll skip that. Don't worry about sampling error for the time being. All right, 2 quick notes about notation and order of operations. Just like in algebra, we're going to be using letters. So the scores obtained are data for individuals. We're going to represent by X in this class. So when you see X, that just means these are the data points collected, the dependent variable collected for participants. If we have multiple scores for a participant, we'll represent an X and Y, just to give you an understanding of what we're doing. The number of participants we have is big N for the population, little n for the sample. And then we use the letter sigma, Greek letter sigma, to mean the sum of. When you see the sigma, that means sum of every instance in which this could be applied. So if it was sigma x plus y, that means for every participant, add their x value and add their y value. And then add all of those up. Does that make sense? And then you all should remember PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. But in case you don't, because this is a math course, you are going to have to remember the order of operations. So when you see an equation, do everything in the parentheses first. Once you've done everything in all the parentheses first, you then do everything that has an exponent. You then move on to anything multiplying and dividing from left to right. So if the first thing is a division, you do that first, and then you can do the multiplication. Okay? So it's multiplication, division, grouped. You do anything with the summation, the sigma, and then finally, you're doing the addition and subtraction, again as a group from left to right. All right. What questions do we have about what we covered today? Says, why did my nose get so freaking bad right now in math? Yes? The quasi-experimental, you said? Yeah. So quasi-experimental is there's going to be variation out in the real world for certain variables. But we're not going to assign people to those variables. And so let's say we wanted to know the difference in IQ levels between UAB, UAH, and UH exclusive students. We're not going to assign high school seniors to go to one of those 3 schools. We're going to take people from those schools and look at their IQ. Yes, in the sense that there's normal variation out in the world, and we're just leveraging that normal variation. We're not assigning people to those different groups. Yeah, and so also with color. So let's say, are people who like the color blue more likely to be empathetic than people who like the color red, right? We're not assigning you to like blue. We're saying, what's your favorite color? You like blue? Okay. What's your empathy? We'll get that. And we ask somebody else, oh, it's red, we'll get their empathy there. So it's quasi-experimental because we're not assigning people what their favorite color is. They have a favorite color, and then we're just leveraging the fact that they already have a favorite color in that case. Does that make sense? Other questions?
Will you typically have, two things, will you typically have like some objectives for the chapter?
Not declared. So I would struggle with that because, like, the things that I think are important to remember are things I'm talking about in class. And so with statistics, I think it'll be a little bit easier in the sense that, when we talk about how to run a chi-square test, the objective is just know how to run a chi-square test. I know that sounds kind of overly simplistic, but if you have questions throughout about, if I'm not being clear enough about anything in the semester, please don't hesitate.
I just asked that, will the PowerPoint be uploaded prior to the class?
They will be moving forward. I just totally spaced on it today.
Gotcha, okay.
Thank you.
And one more, sorry.
Yeah.
I read before the class, some of the stuff that we didn't touch on, is that imperative or?
So I would know it. I think it helps to know it. In large part because it'll help kind of inform additional concepts later on. But it's not like I'm going to not teach y'all how to run a certain statistical test and then expect you to replicate it on the exam.
For exams,
Mhm.
what kind of calculators?
You can get by with the most bare bones 99-cent one you get at the grocery store, as long as it has the ability to do multiplication, division, addition, subtraction, square, and square root. Any other questions? Exams, will you ever try to trip us up with any trick questions, or will it be more so straightforward what you're asking for? So if I'm going to try to trick you up, I probably wouldn't tell you I'm trying to trip you up, because that would defeat the purpose of tricking you up. I'm definitely not going to try to trick you. There will be cases that there are kind of general points of confusion for people, and I will ask questions that kind of leverage those points of confusion, but I'm never going to deliberately try to trip you up. Hopefully that helps. Anything else? Awesome. Thank you all for a lovely first day. Have a great rest of the week. I will see those of you all on Zoom in class and in class on Zoom next time. No study guide, Samantha. Sorry.